All right. Okay. Okay. Piecewise functions. Oh. Back there to her. Jaden, go to the bathroom.
He's fired.
Might have to pick a new assistant next time. We'll see who can. All right. Okay. Piecewise functions. I need everybody with me. Your computer should only be on Desmos. Hopefully I've got you locked there so you can have it up. Oh, wait. That one's not. Hold on. Some of y'all are not claimed. Gotta claim you. I don't know why. Okay. All right. So for piecewise functions are whenever we take pieces of functions and stick them together. Okay. So here is an example of what a piecewise function looks like. Okay. You can see right here the equations look super crazy. There's a lot going on here, right? You got brackets, you got inequalities over here, you've got whatever type of equations you have here. And then your graph has different pieces. Okay? You can see right here we've got a line. Then what does this look like right here? Do I remember the name for that shape? There, almost accidentally raised his hand. Starts with a P. Parabola. You guys remember here parabola? That's a parabola right here. And then here you got another line, right? So what this tells us here is that negative x minus 2, that is the graph of a line. Do you guys remember y equals mx plus b from math 1, right? That was how we graphed a line. This is a line. So whenever x is less than 0, right here's 0, x is less than 0 on this side, this piece of the graph, that is when we use this line. So it gives us the equation of that line, right? Then from 0 to 4, so that is here, 0 is right here, over to 4. It's this part of the graph. We have this equation. What tells us it's going to be a parabola is that square right there, right? So in Math 2, you talk about quadratics a lot, things that are squared. So you may or may not remember those things, but that's going to make this parabola shape right here. And then the last part is from anything bigger than 4. So x is greater than 4 here. And this is another line that we have right here that is graphed. Okay, so those 3 pieces are put together. Okay. A lot of the problems we're going to do are going to do things with stuff like this. It's really just a math problem, right? Like we don't see a lot of application for that. We don't really know why we're doing it. There are a lot of places that piecewise functions are applied. We are not going to have time to get into those. They don't really put them on our EOC, and they are kind of difficult, some of them. But like a really good example is your tax brackets. So whenever some of you guys have a job where you get paid, if you get paid legitimately, not under the table, somebody hands you $20, then they're not taking taxes out. But if you get paid a check every week, you might make $10, $12 an hour, but when you get that check, is it for the full amount? No, they pulled those taxes out. But you guys probably don't make much money in your part-time job. Now, probably pretty good part-time money, but you're probably in the lowest tax bracket, right? Because while you're probably, hopefully, paying for gas and maybe cell phone, going out to eat, fun stuff, do you think, those of you with part-time jobs, that you could afford rent and food and gas and everything just on your part-time job? If so, your part-time job may be illegal. Now maybe in the summer you might be getting closer. If like some of you work close to full-time hours in the summer, but unless you're working close to full-time hours, you're gonna have a hard time doing that. So you don't make much money, so they don't make you pay as much taxes. If you have not, you'll have to file your taxes at the end of the year. You'll probably get some of that money they've taken out back because you are in the lowest tax bracket. But as you make more money, they take more of your money in taxes. So as you make more, they start taking, instead of taking like 10%, they might take 20 or 30 or 40, depending on how high you get and what tax bracket. I don't know about this top. You do not get, no. I've had to, well, last year I did get some money back, but I've had to pay big extra at the end of the year, like 3 years in a row before that. But so your taxes pay for me to be here to teach you lots of things. Your taxes pay for the roads you drove on to get here. They pay for the police officers that are keeping, like taxes pay for all of those common things that we all use, right? So taxes pay for a lot of that stuff. So when you guys pay taxes, you get some of the money back just because whatever they take out of your check is an estimate of how much you will owe. Especially for you guys where you're part-time, like some weeks you might work 10 hours and others you might work 25, right? So it's an estimate of what you're going to owe. A lot of times it will be a little high, so you'll get money back whenever you file your taxes. If you're like, when you're older, you might have to like claim dependents. Like you get some money back, like if you have kids, or there's different things like interest on your mortgage. There's too many things to cover. Yeah.
So another way to explain piecewise and income, you guys want to think visually, and you correct me if I'm wrong. Is it like a road? If there's a break or change in the road under construction, then it continues on. That's kind of how to think about it.
Yeah. Yeah. So, like in your tax brackets, as you go up, they start using a different formula, right? So down here, like if you're in low tax bracket, you're only maybe 10%. But as you go up, they're going to take a bigger portion. Yes, in general, yes. Yes. There are also, especially when you're an adult, and you have kids, there's like child tax credits and different things. So, yes. And like for me, I had to pay extra the last 3 years. I changed it to where like I do have 2 dependents, but I changed it where I was claiming none of them. So they took a little more out of my check every week, so that I would not owe extra money at tax time. And so this past year I didn't actually have to pay it. I got some back this time. So sometimes you have to like adjust that. The other thing that like they're not figuring it on is like they're doing it on my income and they don't necessarily know how much my husband makes. So like they might take out too much or too little. I feel like they should be able to get that closer than they do sometimes. Especially for me, I work the same. Like I'm salaried, I get the same paycheck all the time. It's not like I work 10 hours when making 25 the next. But anyway, but tax brackets are a great example. We got a little sidetracked on taxes there, but they're an interesting to look at. Most of the problems we're going to do are mostly going to be math problems. Okay, they are not going to be so much real life problems. A lot of this class is getting you ready to go to a higher level, but we don't have time to get into the really interesting stuff. So, here, each one of these pieces of the function has a domain where it applies. Okay, so I only use this if my x is less than 0. I only use this one if x falls here. I only use this one if x is greater than 4. Okay, so if we are evaluating a piecewise function, you have to pick the piece you want to use and plug the number in. Okay, to pick the piece, you're going to look at your number and you're going to see where it falls. Is 4 less than 0? No. Is 4 between 0 and 4? Yes, because we have the or equal to sign right here. So see how we have that or equal to sign right there? So 4 is going to go right here in that middle piece.
you only use the middle piece, okay? So you're going to plug it in. You're going to have 2 minus parentheses 4 minus 2 squared. So all we did there is right there where we had the x, we put the 4. Okay? So we're going to evaluate that. You could type it into the calculator. We're going to do it by hand just for good practice. Okay? Orlando, what would I need to do first to figure out what this is? Okay, order of operations is PEMDAS. The P stands for parentheses. Can I do what's in the parentheses? 4 minus 2? Yes. What will I get, Orlando? Good. Okay, so we've done our parentheses. Then E stands for exponent, so I got to do that next. Jalen, what is 2 squared? Yes, good. 4. So I got 2 minus 4. And last, I just got to subtract. And Uriah, what will I get for that one? -2. Good. Good job. Okay, you are only using one piece. Don't plug it into all 3 of these. I see kids do that a lot. Okay, just one piece. You got to pick your piece first. So, Lily, if I'm looking at example 2, which piece of the piecewise function do I need to choose? The top, the middle, or the bottom? The top one? Okay, I see a 0 here. That makes me think top one. But do I have an or equal to sign with it? No. I also see a 0 here. Do I have an or equal to sign with it? The little line underneath? Yes. So you're looking, if it's one of those breaking points, and they'll give it to you a lot because those are the ones that are confusing. If it's one of those breaking points, right here, the 0 and the 0, you want to pick the one where there's the little line underneath because that's the or equal to. So we want to go with this middle one right here again. So same one we just used, but this time we're plugging in 0. So we got 2 minus 0 minus 2 squared. Order of operations, what do we have to do first, Jacob? Good. What is that going to give us? Perfect. What comes next, Isley? Exponent, what am I going to get? Good. And what do I get for the answer for this one? What is it, Gerardo? -2. Right there. Same answer, right? Just happen to be the same answer. They're not always the same answer. Okay. Let's look at the last one. Trendon, which one should I pick for 8? Should I pick the top, the middle, or the bottom? Okay, the bottom, because this is where x is greater than 4, right? 8 is greater than 4, so we want to pick that last one. So this time, I'm going to have -1/2 times 8. What is -1/2 times 8? When you're multiplying something by half, you're finding half of it. What's half of 8? 4, and it should be negative because one of these numbers is negative, right? So get -4. Just from the equation, because we are using this bottom one right here, so it's just from the equation. Okay, questions? Yes. Yes, do you have a pass? Okay. All right. Okay, let's talk about how to do it from a graph. All right. Okay. Let's talk about how to do it from a graph. This is the same graph. It's the same function. Okay. If I want to find h of 2, it means I'm plugging in 2. That means 2. Oh, sorry. Let's erase that. All right. 2 is my input or my x value, and whatever I get out is my output or the y value. So what you want to do here is you want to find the place where you have an x coordinate of 2. So I'm going to go, right here is 2, and I'm going to go on the graph. I'm talking about this point right here. Okay? Skylar, what are the coordinates of that point? 2, 2. Very good. There. So my input was 2. My output was also 2. So right there's my answer. The y coordinate is just your answer. Okay? So if it asks me to find h of -2, that means that this is my x and my answer is going to be my y. Okay? So if I look at the graph here, -2 falls right here. It's also just the point where we hit the graph for that one. Alex, what are the coordinates of that point? -2, and what's the y coordinate? Okay, if it's on the y-axis, you don't go up any, so it's 0 for that. So -2, 0. So the answer is 0. Okay, so it's just the y coordinate of the point. This is the case for any graph, not just the piecewise. It's just they ask these questions a lot with piecewise. All right, then, so this one, 0 is your x. Your answer is going to be your y coordinate. Okay, so if I look, right here is where my x coordinate is 0. It's going to hit the graph right here. Jalen, what are my coordinates right here? What's the x coordinate? 0, -2. So 0 is what I plugged in. -2 is the y. That's what I get out. So that is my answer. Does that make sense from a graph? That's all you got to do. Your answer is just the y. You got to find where the x equals that, and the answer is the y coordinate. And that's for any graph, not just piecewise. Okay? All right, here's a graph that's a little bit harder. Okay? My first point is f of 2, which means I'm looking for the point where my x coordinate is 2. 2 is right here on that x-axis. Okay? So if I go up or down to find the point, it's right here. Let's see. Kyla, what are the coordinates of that point? 2, -1. So what is the answer to this problem? -1. The y coordinate is your point. All right, Brian, -3. Oh, -3 is right here. This one's going to be harder, right? Because I hit 2 different places right here. Which one do I pick? What? The closest is the closed. It's the one that's colored in. That open circle means we're not actually counting that point. So we're going to pick this point right here, that top one, not because it's on the top, but because it's colored in, right? So if you have 2 spots, there should be just one that you pick there. Oh, this one's a little tougher. What are the coordinates of that one, Brian? Good. So we got, but our x coordinate is -3. Our y coordinate is 2.5. So our answer is going to be 2.5. It's the y coordinate. But you got to be careful and make sure you pick the right point on that. Because a lot of kids will say 1, and that'll be the wrong answer for that one. Okay? All right, let's look at -1. Okay, -1's right here. Ooh. I got 2 points again. I got this one here and this one here. They both have x coordinates of -1. Which one do I pick? Do I pick either one of them? Did we include the open circle the questions? No, those are not included. So there is no point for you to pick here. If you only have holes, if you only have open circles, then there's nothing for you to pick. It has to be either a solid line or a closed-in dot for this. So, does anybody remember what we call this? It's not no solution. Although, you might could get by with it if it's one where you're writing the answers down. I might be kind enough to give that to you. It starts with a U. Nope. Although that kind of makes sense, but undefined. That's it. Undefined. It means that when we plug in a number, we don't get a defined output out. Okay? Our last one is f of -4. -4 is right here. I'm talking about this point right here. Jaden, what are the coordinates of that point? Okay, so we always start right here at 0, 0. You do your x's first, so we go to the left 4. And then how far do we have to go up, Jaden? 2. So we'll have -4, 2 for that one. So our y coordinate is our answer. We'll get 2. Okay, questions? Oh, what y'all made?
It's a fruity pebble Rice Krispie treat thing with white chocolate.
Thank you. We'll put this in my closet.
All right. Try the next one on your own. I'll see what you get on those. I'm gonna freeze my screen so you can't see it. Already did it. If you already did it, you can't do it next. While you're doing this one though, I'm gonna. I think I'm out of graph sticky notes. There's some scissors out there in that cabinet. Could you give every pair a set of scissors? Hopefully, I'm cutting them yet. Yeah, that's right. Yeah, right there. Alright, Uriah, you work with the ones behind whenever we do this, okay? And I think one more second. Okay. Let's look at these real quick. And then we are going to learn how to graph it. Okay, so let's see. Madison, what did you get for number 11? Very good. We're talking about this point right here. Coordinates 0, 2. So 2 is our answer. Beautiful. Skylar, what about f of -4 for number 12? 1 is correct. Very good. So this point right here, x coordinate is -4, y coordinate is 1. Beautiful. Gerardo, what did you get for -1? Oh. It is defined because one of them's colored in. Okay? That bottom one's colored in. So it's going to be -2 because those points right there are -1, -2. Okay? All right. And Jalen, what about number 14? 3. Beautiful. This point right here, 3, 3. So our answer here is 3. Very good. Does that make sense from the graph? Okay. Let's learn how to graph these ourselves. Okay? To do that, you need to remember y equals mx plus b. Okay? What does that b right there stand for? Your y intercepts, which is like moving the graph up or down. There, you can think of it that way too. So it's your y-intercepts where you cross the y-axis. What's this m right here? Not your starting. It doesn't start with m. It starts with s. Slope, I heard it. Slope. Slope. How do we do slope? Like if we're graphing something and it has, like what's the slope of that top line? 1/2. It's the number next to your x. How do I graph a slope of 1/2? Up 1/2. It's rise over run. You go up or down first. That's your top number. Left or right for the bottom number, right? So, you should, between the two of you, you should have 2 sticky notes. I need one of you to graph y equals 1/2 x minus 3. Okay, one of you graph that one. And the other of you is going to graph x plus 1. What number's in front of the x right here? There's a 1 that we can't see. All right, graph those 2 for me. If you are the third person, oh, do you have 2 sticky notes? Are you sure? Check and see. Oh yeah. Okay. All right, graph both of these. One of you graph one of you graph the other. If you are the third person, you make sure they're graphing it right. And make sure you graph it neatly and graph the whole line all the way out to the edge of the graph. Start by graphing your y-intercept, then use your slope to go up or over. Yes. Let me see it. Which one were you doing? No. No. Yeah. Okay. Our graph line.
Your y intercept. What's the y intercept of that graph? So you need to start to start from the Alright, what's your line? Okay. This is good, but keep on going. Same thing. Good. All the way down. Okay. Yes, that is good. Yeah, that's fine. Okay. All right.
Here, I'm gonna actually let me get the document camera on, so we can make sure. Some of us have definitely forgotten how to graph a line. Definitely. Some of you've got it. So let's look at how to graph a line here and make sure yours is right. So let's do that. Y equals 1/2 x minus 3 first. Okay? So y-intercept, what is it? -3. That's where you start from. So you're going to start by putting a dot right there on the y-axis at -3. So if you had this one, and you don't go through that point right there, this one right here, you need to erase it and fix it, okay? And then the slope for this graph is 1/2. That is rise 1, run 2, up 1, over 2. So you're going to go up 1 over 2, up 1 over 2, up 1 over 2, like this. You also can go down 1, left 2 to get the other side of the graph. Okay, do y'all see? Everybody's fixing theirs if it does not look this way. Okay? We're going to connect all our dots. There is our line for y equals 1/2 x minus 3. Okay? If you're between you and your partner, whoever had y equals 1/2 x minus 3, make sure theirs looks like this or your graph will be wrong. Okay? All right. Then here, I'll leave it up here in case you need it. Oh, it's fuzzy, isn't it? Okay. Then the other one is y equals x. Was it plus 1 or minus 1? Plus 1. Okay. So Josue, what is the y-intercept of the graph for y equals x plus 1? I think it's unless they're yeah, it's positive 1. It is that plus 1 that we have there. So your graph should go through 1 on that y-axis. It should go through this point. That's where you start from. Some of you had the right slope, but you didn't start from the right point. And now, there's no number in front of this x, but there is an invisible 1 there. 1's not a fraction, though. How do I make it a fraction? Up 1 over 1. Just put any fraction, any number, you can make it a fraction by putting it over 1, right? So I'm going to go up 1, right 1, up 1, right 1, all the way out this way. And then go the other direction. And you're going to draw that out. And so you should have these two graphs. Double check, make sure they look good. Okay? Alright, now, this is what we do for a piecewise function. I think this is kind of helpful to actually, like, literally cut. Okay? So, whoever, one of you, take the scissors. Okay, let's look at our equation. Here. Actually, I got the note sheet right here. Flip it over so we can see it. Alright, for that equation, I have got 1/2 x minus 3. I'm only supposed to use it for the domain of x is less than -2. Okay? So I want you to make sure you've got the one that was 1/2 x plus 3. Sorry. Right there. I don't know what's happening. There. Get the one that is 1/2 x plus 3, or minus 3. Look at where x is -2. That's right here. Right? And I want you to draw yourself a dotted vertical line right there. So, draw yourself a dotted vertical line at -2. This is our cut line. We're going to cut it here in a second. Okay? Yes. So, it's going to work the same for both graphs. In fact, our other graph is where x is greater than or equal to -2, right? We could do the same thing on our other graph. So let's do it on our other graph also. Dotted vertical line at -2. Both graphs should have a dotted vertical line at -2. Alright. So we're going to take this first one. We're going to take the scissors. We're going to cut it. Okay, that gives you 2 pieces of the graph now. Which one of these 2 pieces should we keep if we're looking for x is less than -2? The right or the left? Left. We need to keep the left. Take your right piece, ball it up. We're going to throw it away in a minute. Don't throw it right now. The left piece is the only piece we need. Okay? Now, we're going to do the same thing with our other graph. We're going to cut it. Cut it on that dotted line. You're going to have 2 pieces of that second graph. This time we're looking for x is greater than or equal to -2. Alright, which one do we need to keep? The left or the right? Keep the right. This is where we got those numbers bigger than -2, right? So take the left piece right here. Ball it up. You don't need it. The left piece of that second graph, yeah. So, what you should have left should be a full graph, right? You could take these 2 pieces and you can just line them up. Put them together right there. Oh, line up that x-axis. That's what you really got to have lined up. Okay? Line them up. That is your piecewise function. There's just one extra thing you have to do. Okay? It is literally just pieces of the function, right? It's like you're cutting them off. Okay? Now, there's one more thing we got to do, and we're going to do it, and then we'll be done, so stick with me. Don't pack up yet. Okay? Now, this is 1/2 x minus 3 is used for x is less than -2. Do I have an or equal to sign with that one? No. Which means I'm not supposed to include the end point right here. I'm going to make that an open circle because I don't have an or equal to. But for this one, it is an or equal to, so I'm going to make it a closed circle right there. And so if I had more sticky notes, I would have given them to all of you so that you would have this on your paper to look at. But I didn't have enough. So one of you is going to have this graph. The other is not, but I think it'll be okay. It's mostly for getting an idea. Tomorrow we're going to work on a delta math with this and move on. So we did not get to the point where I want to assign that delta math, so there is no homework for tonight. No homework. Yes, if you did not, well, let's see. Oh, yes, because I need to get that printed for you. Yes. You come back for that. Everybody else that didn't take the quiz yesterday, go check in with your EHS time teacher. Come back so that you can take that quiz for me.